So in this video, I'm going to show you how to do this. I think it's item 3 maybe, and the review assignment. We're supposed to write but do not integrate a definite integral that computes the volume of the solid generated by revolving the region bounded by the graph of y equals x squared, the line y equals x between 0 and 1 about the y-axis. So that right there is key to telling you we're going this direction, which means that we're going from right to left. So right, it's going to be a right minus left when we integrate it. That also tells you need to be in terms of y. Okay, so I need to solve both of these for y. So I'm going to solve this one here for y by taking the square root of both sides. So I'd have y equals the square root of x. And then, I'm sorry, that is not, I'm trying to solve for x, not for y. I have square root of y equals x. And then the other one that I have is basically, I'm just going to write it the other way, x equals y. So those are my two functions here. So this is the x equals y, and the other one is the square root of y. Just so you can see it in the graphing calculator, my red one is x squared. When I turn it on, I just get this chunk of it for the x equals square root of y. There's my line y equals x. There's my line x equals y. I mean, they both have this intersection point here at x equal to 1 and technically y equal to 1 as well. And that's actually, we really should have looked at that because you're going to have to technically do that in the y direction. So it's really x, but it's 0 and 1 no matter what. So we kind of get away with that. So because I am only touching in one point, I know that I'm working with a washer. Okay, so I've got to do right minus left, and I'm gonna set this up. I know I'm doing an a rotation, so I know I'm gonna start with pi, and then I'm integrating. I know I've got to go from 0 to 1. I know that I have to do my outer squared minus my inner squared, and in this case we're in the y direction, so we're going to use dy. So my outer, the one that's further away from axis of rotation, is my green one. So I'm doing right, which is the green, minus the left, which is 0, right? This is a 0 value. So my right is the square root of y minus 0, the axis of rotation. Now I'm going to do my left, or my inner function, and then I'm going to do right minus left. So my right is the y, and then my left is that axis of rotation 0. And then in order to get the answer looking exactly like what we have typed into Otis, we're going to simplify this. So we've got pi from 0 to 1. When I simplify this right here, the 0 part doesn't matter. The square root of y squared would just be y. And then I'm going to, the 0 doesn't matter again. I just get minus y squared dy.